Let's talk one more time about graphing sine and cosine functions. The example that we'll do is y equals negative 1/3 sine 3 theta. Remember, theta is the same as x, it's just a variable that represents an angle. First, let's talk about what the amplitude of this function is going to be. The amplitude of this one specifically is going to be the absolute value of negative 1/3 or 1/3. Let's mark 1/3 on here. Let's let that be 1. On second thought, let's let that be 1/3. That way we can see really well what our graph's going to look like. And that means that 2/3, that 1 is somewhere way on up here, and that negative 1 is somewhere way down here. But that doesn't matter because the amplitude tells us how high up and how down low the function's going to go. Now let's talk about the period of the function. The period helps us decide how we're going to label the graph. And it equals 2 pi over our k value. The k value is the value that's right before the theta. So 2 pi over 3. That can't be reduced, so it's going to complete a full cycle before 2 pi over 3. Now when you're doing this, you need to have your unit circle right in front of you and use that to graph the function. How do we want to graph it? Well, since our period is over 3 and we need to get to 2 pi over 3, let's go ahead and graph it in 30-degree increments. You could also probably do it in, no, you know what, 30-degree increments is probably going to be the best. So let's start with pi over 6. And then our next one would be 2 pi over 6, or pi over 3. Then 3 pi over 6, or pi over 2. Then 4 pi over 6, or 2 pi over 3. Now you see how this function is going to complete a full cycle in that little bitty area. So we're just going to need to pay attention to each of those values and make sure that we get them right. And let's make the mark on the next one too. That's 4 pi over 6, just 2 pi over 3. So then 5 pi over 6 would be this last one here, just for extra good measure, right? So let's look at pi over 6. When we put pi over 6 into this function, we let our theta, now we'll start with 0. I always forget to start with 0, but it is the easiest one to start with. Start with 0 for theta, and we're going to put it in, we're going to say y equals negative 1/3 times the sine of 3 times 0, because our theta is 0, so that's 0. Looking at your unit circle, what is the sine of 0? The sine of 0 is 0. So, I'm changing my color to graph it. The sine of 0 is 0. Negative 1/3 times 0 is still 0, so we're going to put a mark right here. Now the next one I'm going to put on there is pi over 6. Negative 1/3 times the sine of 3 times pi over 6. 3 times pi over 6 is 3 pi over 6, or pi over 2. So what I really have is negative 1/3 times the sine of pi over 2. What's the sine of pi over 2? The sine of pi over 2 is 1. So this is negative 1/3 times 1. This value here will be 1. Negative 1/3 times 1 is negative 1/3. So let's mark that on our graph. Pi over 6 down to negative 1/3. Now we're going to put in pi over 3. Negative 1/3 times the sine of 3 times pi over 3. Well, multiply this first. 3 times pi over 3 equals pi. So then what I'm really finding is the sine of pi. The sine of pi is 0. Negative 1/3 times 0 is 0. Okay, so it looks like I've got my valley there. If we wanted to just make an educated guess, if you put in pi over 2 there, we're pretty positive that our value is going to be 1/3 because of the pattern of the function. And then go back down at 2 pi over 3 and 0. Now, oops. You can verify these values if you want to, and then 5 pi over 6 seems logical that it would be down here, and so on. Remember that the function has to touch the amplitude. You can even guess, not even guess, make an educated answer of what your sine value of, or the value of this function, what the y value would be at negative pi over 6. It's going to be 1/3 because that's next in order. 0, negative 1/3, 0, 1/3, 0, negative 1/3, 0, 1/3, on and on and on. But what we really needed to graph was this one period of the function. All you ever really need to graph is one period of the function. So we see how we decided to label it. We decided to label by pi over 6's because the period had a 3 on the bottom. If the period has a 3 or a 6 on the bottom, it's always best to label by pi over 6's. This period is also exceedingly small. It finishes a full cycle by 2 pi over 3. That's pretty small. That's less than pi. So if it's less than pi, you'd want to label it pretty small with pi over 6 instead of using pi over 2 or pi. Let's try another one. Let's graph a sine or cosine function. Well, let's graph a cosine. Let's say y equals three cosine 1/2 theta, or 1/2 x. So we know we're going to look at the amplitude. The amplitude of this is going to be 3, the absolute value of 3. The period will be 2 pi over 1/2, which is 2 pi divided by 1/2. 2 pi divided by 1/2 or is the same as 2 pi times 2, 4 pi. So we know it's going to take all the way until 4 pi to complete a full cycle. So what I'm going to do, because I know it's going to go to take till 4 pi, I'm going to label pi, 2 pi, 3 pi, 4 pi. Now you see, between each of those, I left myself one little blank space. What's between 0 and pi? Well, that'd be pi over 2. I might not need to use pi over 2, but if I'm not sure of my graph, if I get an answer for pi that I think is funny, I'm going to go back and check what the value is at pi over 2. And I know my amplitude is 3, so I'm going to go up to 3 and down to negative 3. Easy enough. So I'll check my theta values against my y values. Again, if you can do it without the chart, just use the chart for your reference. I like it as an organizer. So if theta equals 0, I don't want to ignore the negative side of the graph either. If theta equals 0, y equals 3 times the cosine of 1/2 times 0 is 0. So the cosine of 0, look on your unit circle, cosine 0 is 1. 3 times 1 is 3. So the y value at 0 is 3. Plug in pi. 3 cosine 1/2 times pi. Do the 1/2 times pi first. 1/2 times pi is pi over 2. The cosine of pi over 2. The cosine of pi over 2 is 0. So 3 times 0 is 0. The value at pi is 0. It looks like I'm going to get a pretty good pattern here without using this pi over 2 value. So I'm good without doing that at this point. Plug in 2 pi. 3 times the cosine of 2 pi times 1/2, or 1/2 times 2 pi. That's kind of messy over there. Let's erase some of this stuff above. Do this multiplication first, and then do the cosine. 1/2 times 2 pi is pi. The cosine of pi is -1. -1 times 3 is -3. I'm seeing what my pattern is. It's touched the bottom amplitude. It's probably going to go back to 0, but I'll double check. I'm going to put in 3 pi. Three times the cosine of 1/2 times 3 pi. Nobody's scared of 1/2 times 3 pi because that just equals 3 pi over 2. We can find 3 pi over 2 on the unit circle. The cosine of 3 pi over 2 is 0. Look on the unit circle. 0 times 3 is 0. And then we can guess that at 4 pi, we're going to be back up here at 3. There's a full cycle. You see we've got half the mountain, the full valley, and the other half of the mountain. You can even check over here at -pi, and you would find that the value would be 0. And it goes on, and it goes on. So there's one full period of y equals 3 cosine 1/2 theta.